2 coming at you. We've got molar mass conversions. So the difference between 7.1 and 7.2 is pretty simple. We're only adding one thing, which is we are now going to be able to convert molecules between mass molecules and moles instead of just single atoms. So we're looking at a group of atoms, right, instead of just a single atom. Remember that a mole is 6.022 times 10 to the 23rd of anything, which means not just atoms, right, but we can also do molecules. So 1 mole of water molecules is 6.022 times 10 to the 23rd molecules of water. H2O, all grouped together. So 2 terms for you. We have molecular mass, which is the mass of a molecule in AMU. So you add up all of the masses of each individual atom in AMU. And then we have molar mass, and I know the two sound very similar, so remember that molecular mass is AMU, molar mass is in grams per mole. So when we scale it up after we have a mole of it. So that's why it's called molar mass, is after you have 1 mole of it, it is in grams per mole. So let's take water, for example. 2 hydrogens, 1 oxygen. If we go over to the periodic table, hydrogen is 1.008 AMU, and oxygen is 15.999. So 1.008 plus 1.008 plus 15.999 would equal 18.016 AMU. Then, if we are scaling up to molar mass, right, if we had 1 mole of it, it would be 18.016 grams per mole. So all that you're doing is adding up each individual atom and the elements that form this molecule. So let's try this. We've got molar mass of 1 mole of CH4. So that means hydrogen, right, 1.008, and we have 4 of those, and then we have 1 carbon. Let's go CH4. So carbon, right, is 12.011. Hydrogen is 1.008, and then we have 4 of those hydrogens. 1.008, 1.008, 1.008. Add those all up. And you get 16.043. Now, if we are talking molecular mass, that's AMU. If we're talking molar mass and we have 1 mole of this, then it's grams per mole. And it's the same process for any other molecule. So CH2Cl2, well, that's just going to be 1 carbon, 2 hydrogens, CH2, and 2 chlorines. So we have 12.011. We have 2 hydrogens, which we know are 1.008 from looking at the periodic table last problem. And then we have 2 chlorines. So what's a chlorine atom weigh? 35.45. AMU if we are in molecular mass. 35.45. 35.45. Now, add that all up. Let's see. Times 2 plus 2 times 35.45 should be 84.927. Okay, 84.927. And again, AMU if you are in molecular mass, molar mass if you have 1 mole of it, that is in grams per mole. I'm going to do one more problem here. What if you had not just finding the molecular mass, right, or the molar mass of something, but what if we had to do calculations with it? Let's say you have 2.3 moles of CO2. How many grams of CO2 is that? Well, we can figure that one out, right? We just need carbon. Come on. CO2 and 2 oxygens, which is 15.999, 15.999 if you look it up on the periodic table. So 12.011, 15.999, gives you 44.009 per mole. And then I'm going to double check the numbers, but I believe we had 2.3 moles of it, right? So let me go back because I am skipping all over the math here. Alright, before we care about how many moles we have 44.009, and we are dealing with moles, so I'm going to put grams per mole. Right now that's CO2. So 44.009 grams per mole. Now, the problem stated that we had 2.3 moles of CO2. And man, my pen is not picking up this angle very well. Okay, CO2. Now, 1 mole of CO2, right, weighs 44.009 grams, which means that we multiply these. Okay, so it's the same mathematical process that you were doing for 7.1. All that you have to do is add up all of the elements first, and then you just do the same sort of unit conversions that you had done before. So 2.3 times the mass per mole means that we will get, what is it, 85.6 looks like. Okay, so 85.6 grams of CO2. So that's 2.3 moles for you. Is that right? 2.3 times 44. It doesn't feel right. Oh, nope. I messed up my parentheses. Yep, okay, double check your parentheses, right? I was wondering, because 2.3 times 44 should have been larger than 80 something. Okay, so this is actually 101.22. Okay, 101.22. My apologies there. There we go. That makes more sense mathematically to me. So if you had 2.3 moles of CO2, it should weigh 101 grams.